I just accidentally put this green mug in front of the camera and looked how cool it is to drink out of this basically black invisible mug. Hi everybody, how's it going? So today is really exciting because we're going to draw a line through our data. And so now that we did generate data, we have the collection of x values and the collection of y values here. Well, now that we have the data, we can just make a prediction for each, only given the x values, at least, well, you would use the y values indirectly because after we call train parameters, you can see train params is of course a function of y's as well. So we do use the y values to fit the model to train beta naught and beta 1, but after we have beta naught and beta 1, we're just using the function y hat. It's just saying beta naught plus beta 1 times the x value, so this x value, this x value, this x value, all of those, we get a predicted value, y hat, and then we're going to draw a line between those values. So that's really what we mean. And we'll look at the MSE later as the sum of the square distance between our prediction and the average of that. So we'd have a prediction, say here, say here, say here. It would all fall perfectly in a line. So let's get those predictions first. So let me clean up first. We have the data here. So here's our generate data function. And really what these are, parameters, I was kind of lazy here. These are data generating parameters, okay? I'll just write data generating parameters because this is not for our model. This is what is underlying the data is this pattern, which in reality, we don't ever know. Of course, we could just make a model. We could read off of these right now, except in reality, we aren't given what the actual model is. We're going to just be given the data here. So I'll write this explicitly as these are the data generating parameters, which we do not know normally. Okay, it's only because we're making data ourselves. So after that, we have the data, which comes in x and y list. Well, we can very easily get predictions. So we can say predictions is equal to what? Well, it's going to be the y hat, okay? So we know very heavily we're going to use y hat, which is based off of parameters and x, okay? So we need parameters here as well. So we need, we'll just say model params is equal to, and we're going to make it look like this, beta 0, and then what? Well, this is just initial values, okay? So it's our whatever the first guess is, which doesn't matter because we know we're going to solve this using the formula with train params. So we can set this to anything. I'll just set it to beta naught to be 0 and beta 1 to be 1, okay? So that would be the line that had the intercept where we set x equal to 0. We'd also have y equal to 0, so our line would go up like this, and it would have a slope of 1, okay? So that's that line. Before we worry about training parameters, because we don't need that, we do to make the right line, but to actually plot a line, we don't really need that yet. So predictions, well, this is going to be a list that's associated with the y values, the x values. It just means that for each of these x values in here, we need to get that value to be, we need it to be whatever the first x value is. So we'll say x0, but it's beta naught. So this same beta naught is above, beta naught plus beta 1 times x0. Which very easily, we already have this as a function, that's going to be y hat. So given our parameters and the x, that's what it returns. Okay, so sorry about this. We can do this right here. It's going to be the list of just the y hat of all the x's. So let's make this as instead kind of a function, which is going to be define get predictions, which has nothing to do with the actual y values. It's just the x list and the parameters. Okay, so again, we'll say params, but here we're going to pass in our model parameters. So what we do here is we have, say, y hat list. Okay, so our predictions, or I'll just say our predicted y values, is going to be this empty list at first. We'll go through for I in range of, well, n. And what is n? Well, n is just the length and you write that in Python as len, the len of x list. Okay, that's how many data points we have, so that's how many predictions we're going to have. For I in the range of n, we are going to do, well, predictions, I'll do it as prediction I is equal to y hat of params, so the same params, we're doing nothing but passing them along, the params and the x value, which is simply x list sub I, and if you'd prefer, I could write it as xi is equal to x list sub I, and then that's xi. Okay. So I hope that makes sense. That's our predicted value, predicted y value for that x value. And since we have that, we can just do predictions dot append with prediction I, and then we'll return predictions. Okay, so this should be a list of just values that are associated with the x's. We could also return the x list as well, just if that was convenient, but we don't really have to. And so we'll do return predictions, and then I'll say predictions is equal to, well, get predictions of the x list, which is up here. That's according to our data. So we pass in that x list of data and our model parameters, which are just dummies for now. So, but the point is that it's given whatever parameters you're given, okay, whether they're good or bad parameters, that's what it's going to draw this line. And so predictions is get predictions of x list and model params. Okay, so we pass in those model params as above, and just to be a little more clear, I'm going to put this down here right in front of it. And so now that we have the predictions, we should at least be able to, if I comment this out for now, we'll see that predictions is a bunch of values which we don't really see if this makes sense quite yet or not. What we can do is, instead of calling xlist and ylist, we can do it with the predictions. Okay, and so now we can see we drew perfectly in a line, and so I'll do plt.plot this line. Okay, and so now all we need to do is just a Python trick to show both of these things at the same time. To get the data points back, it's as simple as plt.scatter. It's exactly what it was. You can actually call both of these things in a row and it works totally fine. So here's the x's and the y's along with the predictions. And first you'll see this is the wrong color. And so I'll just say C is equal to the string of red. So our points are in red and our Y prediction line is in blue here. And you might have thought we did something wrong here, say, oh, that line doesn't fit the data. Well, duh, actually, we picked some random values. We said 0 and 1. And so you can see for sure that if you set x to 0, we get a y-intercept of 0. That makes sense. And beta 1, which means if that's 1, that means when I go from 0 to 1, that's going from about 0 to the value of 1. And so this slope, it clearly is the line that we said it was, but we don't want that line. It's as simple to get the predictions that we do want to do this. We just do train params with the xlist, ylist, and then our model parameters. So now it's going to actually, this model or this function just changes model params. It changes these values in here to the ones that we want. At least I hope so. Let's call it. And name n is not defined. So let's see where I have an error in the function. Going up to train params, we can see that we are using n before we got the value of it. And so n is the length of the x's or the y's, either is fine. We will try calling this again, and we see instead that another error. I'm quite certain that if you watched me do this earlier, you would have caught that I didn't write return here. It's simply that the mean function wasn't returning anything. And now if we do it, we can see that we have a crappy line still. Again, you watching, you probably would have seen that there's an error here where it should be y bar minus beta 1 x bar. You can see there we go. Our line actually fits the data after we fixed a couple errors.